Welcome back. So we're continuing to graph these things called functions. So let's take a look at a few more. Let's say we have the function f of x equals x squared plus 2x. Now the first thing we want to do is we want to construct a table of values so we can easily pick out points that are on the graph of the function, and all we have left to do is connect the dots. So it's a 1, 2, 3 step that we've been working on, so let's do a few more. So our domain is x, and our range is f of x, or our function evaluated at a given value. So what we want to do is we want to pick out some values of x to plug into our function so we can actually find our range. Now when we're doing this, when we're picking values for our independent variable x, we want to be smart about the numbers that we pick. We don't want to pick abnormally large numbers. We kind of want to stay away from fractions if possible. But what we do want to do is pick both positive and negative numbers. I want to do that because we want to get an idea of what's going on both the positive and the negative side. So there's actually 5 numbers that we usually tend to use by default, and they are -2, -1, 0, 1, and 2. Okay, these are usually the 5 most popular numbers that we'll be using a lot. So let's go ahead and plug these into our function one at a time and get the respective evaluations. So we'll write out the first one. The first one we're going to have is f of -2. So we want to find f of -2. So when x equals -2, we have f of -2 equals, we want to plug in -2 everywhere we see x. So -2 squared, that's this term, plus 2 times -2. Plugging in -2 for x. -2 squared is 4, plus 2 times -2 is -4, and this will give us 0. So our function evaluated at -2 is 0. Okay, now let's do f of -1. Plugging in -1 everywhere we see x. -1 squared is 1, plus 2 times -1, so 1 minus 2 is a -1. F of 0, if we plug in 0 for both x's, we're just going to get 0. Positive 1, so we have 1 squared plus 2 times 1 is 2, so we have 1 plus 2 is 3. And then finally we find f of 2. 2 squared is 4. 2 times 2 is 4, so 4 plus 4 is 8. Okay, so now we have a table of values, and now we can go ahead and graph this function. So once again, we're just making a rough sketch of the graph. It doesn't have to be anything pretty. We just want to get an idea of what it looks like. So this is our f of x axis, and this is our x axis. And when we're finding our scale, for x, we have small values, so we don't have to scale it too much. We can just use the regular, if you want to do 3 or 4 points. Both of them are going in -2 and 2 in both directions. For f of x, the lowest point that we're being asked to solve for is -1. Our function never goes below -1, and we'll actually see that when we graph this thing. But we do see that we have the function 8 up here, so we do want to make sure we include the point 8 right up there. I think that's f of x equals 8. Okay, so we have a point -2, 0 right here. The point -1 and 1, the function goes to the origin. We have the point 1 and 3, and we have the point 2 and 8, and 8 is up here. Okay, now all we have left to do is connect these dots as best we can, and we're gonna assume that, well, the domain is the set of all real numbers, so the function will go continuously in both directions of x, and the range is actually the set of all real numbers, so we know that this function continues infinitely in both directions, in the x and in the positive f of x direction. The lowest that this function will ever be is f of x equals minus 1, which is right here. It'll never go below that. It'll actually just go infinitely to the left up and to the right and up. So very good to know, especially if we're working with a real-world situation here. So let's do a couple more. The next one we have is f of x equals 1 over x. All right, first thing we want to do is make a table of values. So we have x and f of x, and we want to pick some values to plug in for x. So again, we want to stay away from fractions and very large numbers, but we also want to include some negative numbers. So let's go ahead and define our domain as -2, -1. Now notice we can't include 0 into our domain here, because if we plug in 0 for x, we'll get division by 0, which is a no-no. That's called undefined. So what that means is that our function is not defined at 0. So we're not going to plug in 0, but I'm going to show you what it looks like in a second when we graph this thing. So we can skip 0 and just include 1 and 2. And you can include a couple more if you want to, but I'm just sticking with these 4. So let's go ahead and plug in, let's evaluate this function at these given points, or these given values of x. So f of -2 is going to give us 1 divided by -2, which is a -1/2. F of -1 is 1 over -1, which is just -1. F of 1 is 1 over 1, that's just 1. And f of 2 is just 1 over 2, which is 1/2. All right, now let's see what this graph looks like. All right, so it doesn't have to be very big because our numbers are fairly small, which is what we want. This is our f of x axis. This is our x axis. And we can just include 2 or 3 points here. 1, 2, 3, 1, 2, 3. Okay, let's graph a few of these. So we have -2 and -1/2. So that's this point right here. So we have -1 and -1. We have +1 and +1, and we have 2 and 1/2. Okay, this graph is going to look kind of weird, but it's going to do something like this. And the more points that we plug in, we actually get a better idea of what it looks like. Okay, these two lines going in this direction and this direction, this line going in this direction and this direction, they will actually converge on right here. This is going to approach the x-axis infinitely, but it will never get there. And this line going this way will approach the f of x-axis infinitely, but it will never get there. And the same thing will happen with this line. It'll never actually touch the f of x-axis because it's not defined at x equals 0. So in the same case, it'll never touch the x-axis going in this direction. Now it can approach the line infinitely, which is really cool to think about, because it can go forever and ever and ever getting exceedingly closer to the axis, but it'll never actually get there. And when you get up to calculus, you'll talk about things called limits. That's when you approach a point forever and ever, but you'll never actually get there. And it's really, really cool to think about. But there's actually, it'll never touch this axis, and it'll never touch this axis. So it'll approach it indefinitely, it'll never get there. So, and it makes sense because if it does, we'd have division by 0, which we definitely can't have. All right, let's look at one more example. That's a little light. Let's look at the function f of x equals the absolute value of 1 minus x. Absolute value of 1 minus x. The first thing we want to do is construct our table of values. This makes graphing our function much simpler. And here we don't have to worry about division by 0 or anything like that. We can actually pick any points we want, but again, we want to pick some easy ones to plug in and solve for. The simpler math is, the more fun math is. So let's go ahead and solve for f of minus 2. F of minus 2 is equal to the absolute value of 1 minus a negative 2. These negative signs will cancel, so we have the absolute value of 3, which is just 3. So our function evaluated at x equals minus 2 gives us 3. f of minus 1, 1 minus a negative 1, we can cancel the negative sign, so 1 plus 1 equals 2. Absolute value of 2 is just 2. F of 0 is simply the absolute value of 1, which is 1. F of 1 is 1 minus 1, which is 0. The absolute value of 0 is just 0. It's neither positive nor negative. And f of 2 gives us 1 minus 2, which is a minus 1. Whenever we have the absolute value of something, we take the absolute value of minus 1, it turns it into a positive. So we have a positive 1 for f of 2. Okay, so now that we have some points here, let's go ahead and graph them. Now notice the absolute value signs. We're actually never going to have our f of x equal a negative value. So we can actually just stay in the first two quadrants here. Okay, and this makes sense because anytime we take the absolute value of something, we can never get a negative evaluation. We can never get a negative number. So don't have to worry about scale here. These are actually pretty small numbers. But f of x will never go in the negative direction, so we can stick with the first two quadrants because of the absolute value bars. Kind of want to hammer that home because if we can scale this easier, we actually can graph these functions much more easily. So our first point is minus 2 and positive 3. So minus 2 and 3. Next we have minus 1 and 2. We have 0 and 1. We have 1 and 0. So this function actually touches the x-axis, but it'll never go on the other side. And then we have 2 and 1. Okay, so we've actually seen the graph of an absolute value equation before when I pointed out in a previous section. And it looks something like this. And we are going to squint really hard and imagine that this line passes through all these points that I've drawn. Right there and right there. Okay, that's one right there. Okay. The domain and the range are all real numbers. We can plug any number into here. We don't have to worry about 0, division by 0, and we can get any positive number out of here. So this function will continue infinitely in both directions, but it will always be positive. And that makes sense because, again, we do have an absolute value bar here. Okay, so we are graphing equations, and we're taking functions. We're constructing tables to help us graph those functions. We'll do some more in the next section, so I'll see you soon.